Welcome. In this lesson, we're going to learn to find the distance between two parallel lines. Now, if the lines happen to be horizontal, like the two given, y equals 5 and y equals 7, it's not hard to find the distance between two horizontal lines. It's just the distance between those y values. Distance between 5 and 7 is 2. Type in 2 and you're good. Same principle applies if they are vertical lines. Except with vertical lines, we want to find the distance between their x values. If we have a vertical line at -1 and a vertical line at x equals 7, just how far away is -1 from -7? Well, it's 8 units away. So for horizontal and vertical lines, it's fairly simple. The problem is when it comes to lines that are not horizontal or vertical but are slanted. So let's do an example of one of those. So here are two lines that are not vertical or horizontal. Now, I noticed one of them is written in slope-intercept form, but the other one is not. So that made me question for a second, are they even parallel because they have to have the same slope? But if we bring this x over to the right side, I get y equals x plus 1. So they have the same slope, they just have different y-intercepts. And the distance between the two lines is not the distance between their y-intercepts. What we need to do is we need to find a line segment that connects the two lines that's perpendicular to them. So step one is to find a point on one of the two lines. And that's easy. Just take the y-intercept for one of them. I'm going to use this one right here. So I'm going to use the point 0, 1. That's the y-intercept of this blue line here. Now what I'm going to do is I'm going to write an equation that is perpendicular to these two lines that passes through this point of 0, 1. So what's the perpendicular slope of 1? Well, the perpendicular slope would be -1. And remember, it's really 1 over 1, which I flipped upside down, and then I changed the sign. Now I have y equals -1x. Now I got to find the b value. And remember how I find the b value? I'm going to use this given point here. So I'm going to take my b value, or my b value is going to be found by taking my y value, minusing off the slope, which is -1, times my x value of 0. And luckily, timesing by 0, that goes away, and my b value is 1. So my perpendicular line is y equals -x plus 1. Now, let me kind of graph this so you can kind of understand what's happening. Now, here is the graph of those three lines. There's the first line, y equals x minus 2. That's this one here. There's the second line they gave us, which is that y equals x plus 1, which is this green line. And then there's the perpendicular line that I found that goes to this point 0, 1, and is perpendicular. It's at a right angle to those two parallel lines. So I know this point right here is 0, 1. I need to now find the point where that purple line, the perpendicular line, intersects down here. I need to find that point. The way I'm going to do that is I'm going to do either elimination, substitution, or I'm graphing, but graphing doesn't look like it's going to be very easy. But what I'm going to do is find out where this one intersects the red one, because I already know where it intersects the green one because it was the same y-intercept. So now I'm going to solve these two equations for their intersection point. So what I've done here now that appeared is I basically set this top equation, y minus 2, in for this y equals the -x plus 1 right here. This is my x minus 2 equals the -x plus 1. Then what I did is I added x to both sides. I added 2 to both sides to eliminate the x's from one side, from the left side, or right side, I mean, and the constant from the right, got 2x equals 3, divided by 2, and got x equals 3/2. So that is the x value for that point of intersection. Now what I'm going to do is substitute 3/2 back into one of my two equations, either the purple one or the red one, to find the y intersection point. Now I did that just right here. I just took this top red equation, y equals x minus 2, substituted in 3/2 for x, minus 2, that gave me a -1/2. That gives me a -1/2 for the y value of this intersection point here. Now the last thing I need to do is I need to find the distance between this point here all the way over to this point here, and that's the distance between the two parallel lines. And I'm going to use Pythagorean's theorem. I'm going to find the distance between their x values, the distance between 0 and 3/2. Well, that's 3/2. That's the horizontal. Remember, what I'm doing is I'm doing a right triangle. My horizontal distance was 3/2. That's the distance between this x and this x. The distance between 1 and -1/2 is going to be also 3/2. So I'm going to do 3/2 squared, add that to 3/2 squared. And then once I add those two numbers together, I'm going to square root it. Because remember, that gives me the value of c squared, not the value of c. So what I've done over here is I've taken 3/2 squared, that's 9/4, plus another 9/4 is 18/4. 18/4 equals 9/2. Now I'm square rooting 9/2. I'm just going to use a calculator. That gives me 2.121. And it says to, in the problem, round your answer to the nearest tenth. So the distance between those two parallel lines is 2.1. Now, if you need to rewatch all that, please do so, or bring your questions to class. Just remember, what you need to do is find one point on one of the lines, write the perpendicular line that goes through that point and it's perpendicular to the two given lines, find its intersection with the other point, and then find the distance between those 2 points of intersection. Let's see if this is correct. Look at that, awesome. If you have any questions, please do bring them to class.